Hello students, welcome back to video lecture series for the subject Mathematics 3 for all my mechanical engineering students, myself Dr. Ankit Acharya, and today we will discuss about the numerical solution of ordinary differential equation, the next chapter. Okay, and in this chapter we have total two methods basically, Euler's method, that means Euler method, modified Euler method, Runge-Kutta method. Okay, and in Runge-Kutta method, there are two methods: second order Runge-Kutta method and fourth order Runge-Kutta method. Okay, so in today's lecture we discuss about Euler method. Okay, and modified Euler method. Okay, so for Euler method, basically what happened that every time the solution of differential equation is not so easy to find. Okay, so in that case we are using this numerical methods to find the approximate root or approximate solution of the given first order differential equation. Okay, so in Euler method you have to remember this approximation that y1, this is your first approximation, y1 is equal to y0 plus h f of x0 y0, where h is equal to x1 minus x0. Okay, and similarly y2 is equal to what, y1 plus h f of x1 y1. Okay, now you have to use x1 y1 instead of x0 y0. In general, yn plus 1. Okay, suppose you find n plus 1 approximation. Okay, so yn plus h f of x and yn. So remember this formula in general, yn plus 1, that is equal to yn plus h f of x and yn. Okay, so let's try to solve some example using Euler method, that how we can solve. Okay, sometimes some people call it Euler method. Okay, so using Euler method, find y of 0.2, find y of 0.2, and this is a first order differential equation, that dy by dx, that is equal to y minus 2x upon y. Initial value problem, y of 0 is equal to 1. Now y of 0 is equal to 1, that means what, x0 that is equal to 0 given, and y0 is 1. Okay, right hand side whatever the value, that is y0, the value of y0, and in bracket whatever the value, that is x0. Okay, x0 here. So x0 is equal to 0 and y0 is equal to 1 here. Now first of all, write all the data f of xy. This is your function f of xy, y minus 2x upon y. So this is your function y minus 2x upon y. X0 is equal to 0. Okay, x0 is equal to 0, y0 is equal to 1. Now they already mentioned, see what is your h? H is 0.1. Taking h is 0.1, they already given. Okay, so h is equal to 0.1, x is equal to 0.2. Okay, because we want to find value at 0.2. So what that means, what, x0 is equal to 0. Now what is your x1? X1 means what, x0 plus h. So x0 is 0, h is 0.1. So that's why x1 is 0.1. So first of all, you find your first approximation y1 at x1. Okay, now what is your x2? x2 is x1 plus h, or sometimes we can say x0 plus 2 into h. Okay, so that you will get x1 plus h, so 0.1 plus 0.1, so that is equal to 0.2. Okay, that is equal to 0.2. Clear? So next approximation at 0.2 x2, you will get your last approximation y2. Okay, so here you have to go further only for two steps. First you find y1, second you find y2, because you x0 is 0 given, h is 0.1, and you have to find the value of y at 0.2. So first you find y at 0.1 and then 0.2. Okay, clear? So all this value f of xy is given, x0 is given, y0 right here, h, okay, x 0.2, okay, n is what, x minus x0 upon n. We don't need to n. Okay, just find out y1. Y1 is what, y0 plus h f of x0 y0. N means what? N equal to 2 means what? You have to go further up to second approximation. N equal to 2 means, and that is x minus x0 upon h. That means 0.2 minus 0 upon 0.1. Okay. So x1 is 0.1. Now what is your y1? See, this is the formula. Y1 is y0 plus h f of x0 y0. So y0 plus h f of x0 y0. Y0 is what? Y0 is 1. Okay, 1 plus h is 0.1. H is 0.1. So I just write here 0.1. 1 plus 0.1. And f of 0, 1. 0, comma 1. Okay. So 1 plus 0.1. F of 0, comma 1. So 1 plus 0.1. Okay. In bracket 1 minus 2 into. Okay. 1 minus 2, because your function, what is your function? Function is y minus 2x upon y. Okay. So f of 0, 1 means what? Instead of x, you have to take 0. Instead of y, you have to take 1. So f of 0, 1, that is nothing but 1 minus 2 into 0 upon 1. So you will get 1 here. Okay. So 1 plus 0.1 into 1. So y1 is 1.1. Okay. Similarly, you can find y2. Y2 is what? Y1 plus h f of x1 y1. Now what is your x1? X1 is 0.1, and what is your y1? Y1 is 1.1, and what is your f of xy? F of xy is y minus 2x upon y. Y minus 2x upon y. Okay. So put all this value here. So 1.1 minus 2 into 0.1 upon 1.1. Okay. Calculate all this value in your calci. So here you can see that this bracket is nothing but whatever I write here. Okay. 1.1 minus 2.1 upon 1.1. And y1 you already find, that is 1.1. H is 0.1. Okay. So 1.1 plus 0.1 into this term. Okay. And the final answer is 1.1918. Okay. Clear? So the final answer y2, second approximation, that means this is the value of y at point x equal to 0.2. Okay. So that's why we write y of 0.2 is 1.1918. Okay. Let's take one more example. Solve the initial value problem. Dy by dx is equal to what? X root y. And here you can see that what is your x0? X0, this is your x0. X0 is 1, and this is your y0. Okay, y0 that is also 1. Okay, y of 1 is equal to 1. That means right hand side the value is y0, here x0. So x0 is equal to 1. Y0 is also 1. Okay, and you have to find the value of y at 1.5. And h is 0.1 that they given. H is 0.1. So first, what is your x1? X1 is 1 plus 0.1, that is 1.1. Then x2, you have to up to 1.5. So x2 is 1.2, x3 is 1.3, x4 is 1.4, and x5 is 1.5. Okay. So that means what? You have to go further up to fifth approximation. First you find y1, then y2, then y3, y4, and y5. Clear? Okay. So that is very clear. x0 is 1. Please write all the data. This is your dy by dx. That means f of xy is x root y. X0 is 1. Y0 is also 1. H is 0.1. X is equal to 1.5. And n is equal to 5 because of x minus x0 upon h. So 5 means you have to go up to y5. Okay. X1 is equal to 1.1. X2 is 1.2. X3 is 1.3, X4 is 1.4, and X5 is 1.5. Okay, clear? So first we find y1. This is my first approximation. Y1, y0 plus h f of x0 y0, that is 1 plus 0.1 f of 1 1. Make sure that function is x root y. Okay, f of xy. Just I write here x into root y. Okay, so f of 1 1 means what? 1 into root 1. So that is 1. So 1 plus 0.1 into 1 into root 1. So answer is 1.1. Then y2. Okay, next approximation is y2, that is y1 plus h f of x1 y1. So 1.1 plus 0.1 f of 1.1 1.1. Okay, 1.1 plus 0.1 1.1 into square root of 1.1. So the answer is 1.2154. Clear? Now next approximation. This is y1, this is y2, this is y3. Okay, y2 plus h f of x2 y2. So 1.2154 plus 0.1. This is the value of h. F of x2 y2. What is your x2? x2 is 1.2 and this is 1.2154. Just we find here. So f of 1.2 1.2154 means what is your function x root y. So 1.2 into square root of 1.2154. So the answer is 1.3477. Okay. Find y4. y4 is y3 plus h f of x3 y3. So that is 1.3477 plus 0.1 f of 1.3 1.3477. So 1.3477 as it is plus 0.1 as it is. This is, we know that f of xy, don't forget f of xy is x root y. Okay, so when you find f of 1.3 comma 1.3477, so that means this is nothing but 1.3 into square root of 1.3477. Okay, and this is the term. Okay, and the final answer is 1.4986. Similarly, the last approximation y5, that is y4 plus h f of x4 y4. So 1.4986 plus 0.1 f of 1.4986. Okay, and the final answer is 1.67. Okay, so in Euler's method, the general formula is yn plus 1, that is equal to yn plus h f of x and y. Okay, remember this formula. Using this formula you can solve any example of Euler's theorem. Now next one is a modified Euler's theorem. Okay, modified Euler's theorem. Now what is the difference between Euler's theorem and modified Euler's theorem? In Euler's theorem, just we find y1 first approximation only one time, right? Immediately we find second approximation, then third approximation. But in modified Euler's theorem, first we find our first approximation y1. Now first approximation y1, we have to find accurate value. Okay, so that's why this called modified Euler's theorem. See, first calculate from Euler's method that y1 0. Okay, this is exactly our y1, y0 plus h f of x0 y0. Okay, so that is my first approximation of y1. We can say that first approximation of y1. Okay, now again I want accurate value of y1. Okay, very accurate value of y1. So that's why this value is improved by making use of average slope. So forget about the theory. Remember this formula. So y1 1, that means the next approximation of y1, that is y0 plus h by 2 f of x0 y0 plus f of x1 y1 0. Okay, y1 0 just you find here y1 0. Okay, y1 1. Similarly, you can find y1 2. So instead of y1 0, here you have y1 1. Okay, all other terms are same. See, y0 plus h by 2 in bracket f of x0 y0 plus f of x1 y1 1, and which is the second approximation of y1, and you can continue this process. Now when you find y2, instead of y0 and x0, you have to use y1 and x1. Okay, the formula is same. So let's try to solve one more example. Okay, this is in general formula. So when you find the n plus 1 approximation of y1, here you have to put y1 n, that means nth approximation of y1. Okay, and this process will terminate it depending upon accuracy required. Okay, what type of accuracy you want. Okay, and similarly you can find y2. Okay, so y2 0, that is here see that y1 plus h f of x1 y1 y1 1. So here you put y2 0, and again this process is repeated till two approximation of y2 are equal. Okay, so let's try to understand the method using one example. Okay, please try to understand this example very carefully. because the modified Euler's methods example are quite lengthy. Okay, so determine the value of y when x is equal to 0.1, correct up to 4 decimal places, right? H is 0.05, that is already given. Given that y of 0 is equal to 1, dy by dx is equal to x square plus y. Okay, so what is your function? Function f of xy, that is x square plus y. Okay, x0 is 0. x0, see x0 is 0. This is the value of x0. This is the value of y0. Okay, so x0 is 0, y0 is 1, h is 0.05. Okay, and you have to find the value at 0.1. So what is your x1? First x1 is x0 plus h. So x0 is 0, h is 0.05, so 0.05, and x2 is x1 plus h. So that is 0.05 plus 0.05. So that's why 0.1, right? So x1 is 0.05, x2 is 0.1. Okay, so that means you have to find out approximation up to by 2. Okay, dy by dx is equal to f of xy, that is x square plus y. x0 is 0, y0 is 1h, x1. Okay, first approximation y10, that is here you can see that y0 plus h, f of x0 y0, 1 plus 0.05 into 1, that is equal to 1.05. First approximation of y1. Now when you find y1, the first approximation of y1, that means y1 1. So this is a formula y0 plus h by 2, f of x0 y0 plus f of x1 y1 0. y0 is what? 1, h by 2, so 0.05 by 2. Okay, f of x0 y0, that you already find here, f of x0 y0. Okay, what is your function? F of xy is x square plus y. So f of x0 y0, x0 is 0. Okay, and function is x square plus y. Okay, so 0 square plus 1. So that's why this is 1. F of x0 y0 is 1. Okay, f of x1 y1 0. So f of 0.5, 0.05 and 1.05. So put this value here. This is your function. So when you find f of 0.05 and 1.05, that means what? 0.05 whole square plus 1.05. Okay, so that's why they write this step here. Clear? And the final answer is 1.0513. Clear? So y10 is 1.05, y11 is 1.0513, y12. Similarly, you can find y12. That means next approximation of y1, second approximation of y1. That is also 1.0513. Since the value of y11 and y12 both are equal, okay, almost. So that's why now this is your y1 is fixed. Okay, and similarly you can find the y2. Now x1 is 0.05, y1 is 1.0513, h is 0.05, x2 is 0.1. Put all this value in next equation. Okay, so easily you will get your y2. See all the calculation, the formula is available. Okay, you can check all the value y1 h, f of x1 y1, f of x2 y2 0. Okay, so this is quite easy to find out the next approximation y2. Okay, the calculation is already, I write all the steps. Okay, so in today's session we discuss about Euler's method and modified Euler's method. So try to solve more and more example up to this. Thank you.